This is our next IMB on the properties of logs, and we're going to introduce the natural log. Our first property says any log with any base, if the input is 1, the output is 0, and that's because when we ask the question, um, remember from Friday, we're going to ask the question, hey, what power of? So when we say that, when we say, hey, what power of A gives me 1, and you would say 0 every time, right? So these are going to always be 0. And on B, notice the log does not have a visible base. This is the same as log base 10, but just like the square root, it's so common that we don't write the base. So when you see a log, log, and you don't see a visible base, it is always going to be 10. It's a hidden base. Just like the square root, we don't write square root of 4. But if we were going to take the, which is 2, but if we wrote the cubed root of 8, which is 2, we would put the 3 there. Okay, the next one is if you have a log and it is the same, the base and the number and the input are exactly the same, the answer is going to be 1. And that's because you say, hey, what power of 3 equals 3? Number 10, or B is going to say, hey, what power of 10 is equal to 10, and that's going to be 1 every time. The next one, we have another property here, and this one says, very similar to the other one, because if you think number 2, it's really the power of all of these to begin with is 1 here, so, but this one says log of any base. If you can write the input as an exponential with the same base as the log, then the answer is the power. And we looked at these. So same base, 7. Remember, there's a 10 here, same base. The answer's the power, or x. But the same thing goes the other way. Notice that I have an exponential, and in the power is a log with the same base. So it's going to equal the input. In both cases, it will be the input. So this time it's the input of the log, which is 1. Oh, and I forgot to change this base to base 10. So there should not be a base there. Otherwise, like if this was written the way I have it with log base 3, then you wouldn't be able to do anything. So this is log 1, just get rid of that 3. Okay. On number 4, our last property of logs. And these are just nice, easy properties that are going to help us solve quicker. Then we'll notice this is the logs version of, we did the exponential of 1 to 1. So one thing you have to know about the 1-to-1 property is the log has to be the same base, and it's only can be the log and its input available. You can't have anything else added or subtracted. So it's just the log and its input, the log and its input, and then I can just set the inputs equal to each other. And if x was 10, then what would I do? If I plug it back in here, I'd have a log of a 100 equals log of 100. Same thing over here. I'm going to set these two things equal to each other. Notice how the input, if it's big, that there'll be a parentheses holding it, so you know that the 1 is not outside of the input. And I'm just going to solve. I'll subtract 2x, and I get x is equal to 1. So notice if I plug 1 in over here, I get 2 times 1 is 3, is 2, plus 1 is 3. If I plug 1 in here, I get 3, so I get log base 3 of 3 is equal to log base 3 of 3, which then would be, using our powers, you'd get 1 equals 1. Okay, the next is natural log. So we already learned about an exponential that has the base e. Remember that was about 2.718. And we can obviously have a log of that base also because it is bigger than 0. And however, instead of writing the log base e, throughout history, it got changed to the natural log of x, and it's just ln n and x is how it is shown. So you would never see it written log base e. It's always going to be written as ln of x, or what we call the natural log. So we're just going to convert a few of these over from one to the other. So I'm going to convert this to the log. So this is log base e, and I'll take care of that in a minute. Remember, the input of the log is the output of its inverse, and dot dot dot, because this goes on forever. Remember, it's irrational. So if I did e to the fourth, and then the output of a log is the input of the exponential. Okay, and so you would never see log base e. It would always be written as natural log. So I just did that so we could see that that these two things are the same. So you can go straight to the natural log. I can say natural log, that's log base e. The input's the output, and is equal to the output, the input of the exponential. Okay, so log e, which is the natural log, the input is the output of the exponential, and is equal to a, which is the input. If we could go the other way, now I see the natural log, so I know the exponential is base e, and the input is the output, so 0.0693, and then the input of the log is the output of the exponential, since they're inverses. So e raised to 1.4945 is equal to 7. That probably should go forever. And then here's one, e, right, to the 1 is equal to e. So we know that this is just equal to a 1-to-1 property. Okay, so that's the all there is for today, and you're gonna have some delta math um, for homework, um, writing these properties. And I will see you on Monday, Tuesday.